Welcome to the Coaching Lab's Dopamine Unplugged episode, where we're going to dive into the fascinating world of dopamine, our brain's supposed superstar neurotransmitter. Is it really the happiness chemical? Or are there more nuanced truths behind its role in motivation and behavior? Today we'll be debunking common myths, explore the latest research, and uncover how understanding dopamine can empower us to create healthier habits and make lasting change. Whether you're a neuroscience enthusiast or just curious about how your brain works, we've got something for everyone in this one. If you're new to the Coaching Lab podcast, I'm Dr. Brad Cooper, the curious CEO of Catalyst Coaching, and your host over the past 7 years and 344 episodes. We exist. The reason we're here is to provide health, wellness, and performance coaches engaging, practical, and evidence-based insights to enhance your life, support your clients, and bolster your career. If you're not yet a coach, that's fine. We'd love to have you join us as well. Today's guest, Dr. Talia Lerner, will be our guide through today's unplugging process. She's an associate professor in the departments of Neuroscience and Psychiatry and Behavioral Sciences at Northwestern University. She earned Bachelor of Science degrees in Molecular Biophysics and Biochemistry from Yale, her Ph.D. in Neuroscience from UCSF, and completed her postdoctoral work at Stanford University. It took us almost 2 years to tee up this interview with Dr. Lerner, and I think you'll discover it was well worth the wait. If you've been considering pursuing your MBHWC approved coach certification as part of a new career pursuit, or maybe to give you a new tool in your toolbox as a physical therapist, occupational therapist, or other clinician, now's the time. Catalyst Coaching Institute was rated #1 by Fortune magazine, and our first cohort for 2025 kicks off in January, including all the latest updates from the MBHWC and a complimentary study group for those who do want to pursue that national board exam. All the details on our institute site, catalystcoachinginstitute.com, or shoot us an email anytime. We'll set up some time to talk. Results@catalystcoachinginstitute.com. And now, it's time to pull back the curtain on the realities and the myths of dopamine with Dr. Talia Lerner on the latest episode of the Coaching Lab podcast. Dr. Lerner, welcome to the Coaching Lab podcast. Appreciate you joining us.
Yeah, thanks for having me.
Big topic today. Dopamine is something everybody's hearing about. We're hearing about a lot of, I'm not going to say weird stuff, but essentially misinformation about what it really is. So can you set the tone around this concept of the pleasure molecule and how maybe that's not quite so accurate? How would you describe it? What is its real role and function for somebody that doesn't have a PhD in neuroscience? So keep that in mind as you're going through this.
Yes, absolutely. So dopamine is a fascinating molecule. I'm spending essentially my life studying it. I think that it was originally conceived as a pleasure molecule because it is released in your brain during events that we think of as pleasurable. But the idea that it's actually the thing that's communicating pleasure has been fairly well debunked, I would say. What dopamine seems to be doing is enabling learning about unexpected events. And oftentimes, if something unexpectedly good happens to you, someone suddenly gives you a compliment you weren't expecting, or you get a candy, or anything else good in your life, right? Part of that is not just that it's pleasurable, but that it's a significant event that happened to you that perhaps you could learn from. You know, what did I do to get that good thing? And should I repeat the action that led to that good thing happening? And so we think of dopamine more as being about learning and motivating your behavior towards a goal and possibly adjudicating things like when you transition from trying to get towards a goal towards a more habitual performance. But it's really about that learning process more than the experience of pleasure after you receive a reward.
So love that description. It sounds to me like we could see application for parents, for managers, certainly for health and wellness coaches. Where do you see folks maybe taking a initial concept that is accurate and then going off the rails?
Right. I mean, so I think that dopamine's role in learning kind of inspires people to think about, right, how you could use that to learn good things, adaptive, wellness strategies, for example. Dopamine is also probably involved in learning about bad things.
Yes.
So forming bad habits or things like drug addiction, right? And so thinking about how to sort of use our dopamine system for our betterment rather than to solidify things that are damaging to our health is important. And I think, people have been trying to think through, how do we do this? Not just how do we sort of operate hedonistically, right? But how do we encourage ourselves to feel the rewarding effects of sort of more long-term healthful behaviors like exercising, for example.
Mm-hmm. So, okay, let's go down the bad habits path. Where would dopamine kick in with that unexpected events piece? Because I don't know, my brain goes to I have a drink every night. I like to, if drugs are a part of it, it's a pattern more than an unexpected. Where might this concept play a role on that side of the coin?
Right. So all addictive substances seem to have in common that they activate the dopamine system in some way. And if you're talking about sort of a pharmacological substance, an exogenous substance that you're putting in your body, like an opioid or like cocaine or like amphetamine, right? Part of what it's doing is it's chemically activating your dopamine system, regardless of any like actual thing that's happening in your life. But that sort of tricks your brain, right, into thinking something unexpected and especially unexpectedly good happened when really it's just a chemical, right? And that sort of repeated dopamine release that's chemically mediated can help you learn habits that basically lead to repetitions of that dopamine release, which means continued seeking of the drug and continued taking of the drug, right? So because they have this sort of abnormal effect on your dopamine system, they can actually really powerfully activate it, but in a way that's like not connected to, again, like a behavior that actually we want to reinforce, right?
So it's giving a false positive. It's giving this same outcome, the same trigger for something that isn't necessarily unexpected.
Exactly. And then the other role that we think about when we think about addiction as sort of not just that first experience of taking a drug, but the patterns that happen over years that lead to problems. Having one drink or one big night out, right, is not necessarily the worst thing that ever happened, but drinking repeatedly over decades where to the point where you get liver failure is certainly a problem, right? And so the way that we think about that happening also has to do with, there's other reinforcing effects of the drug that start to play in, that it starts to play into things like, releasing anxiety at the end of a hard day, or avoiding withdrawal from the drug itself, which is unpleasant. And when you relieve that withdrawal, that's a good thing that you want to reinforce. And so all of those things start to come into play as well, I think, with the long-term use.
Okay, so we'll get into creating positive changes a little bit later. Let's stay on this for a second. Are there ways we can utilize what we know about dopamine to make some progress with some of these negative habits that we see in our lives? Or help our clients do the same?
Yeah, I think so. And, addiction is a particularly challenging one, which,
absolutely.
I wish I could give a pill for it right now and really solve it. Obviously, if I could do that, I would.
It's coming.
There's some promising things. I'll just say there's some promising things, I think, in the pipeline right now. For example, people exploring GLP-1 agonists like the Wegovy type drugs that seem to have at least some promise for addiction. So there's a lot happening there that I think will be interesting, and probably there's some involvement of dopamine in some way down the pathway of how those drugs act. But for now, I think the other things that we think about doing are finding other ways to use your dopamine system, engage your dopamine system in ways that are good for you and that can sort of replace unhealthy habits. And so, like, for example, a big part of how a drug treatment program like AA works some of that is the specific things that people are actually saying, or the specific 12 steps, but a lot of it really seems to be the social interaction. Yeah. The fact that you go to a place where people accept you and listen to you and share stories and you connect with them. A huge amount of, I think, the positive effects of programs like that is social connection. And social connection is something that can activate our dopamine system in a very positive way and lead to good patterns in our lives, right? So I think that is really important to keep in mind as well, is where can you find things that you want to reinforce that are good for you, and how can you kind of take advantage of that to build good habits that replace the bad ones?
It's interesting you use that specific example of connection. We talk about the 4 cornerstones being move, fuel, rest, connect. And we had a physician that works with GLP-1s, and we'll circle back on this later too. But she mentioned, the coach that was on the interview with her said the connect piece is the single biggest, most important element of those 4 when working with folks that are using GLP-1s. And I knew it was important. We preach it all the time. And yet I didn't think that would be one. I thought that would be, and connection's also valuable. But right. It's fascinating that you use that as the example as well. You're being quoted in national publications, that kind of stuff. That's where we found you. What are some of your concerns about the way in which the term of dopamine, or the concept of dopamine, is being utilized in the pseudoscience-driven podcasts, in the headlines, all those kinds of things? Give us some warning signals of what to look for and be aware of that you're seeing out there as an expert.
Right. So the current discourse around, for example, the idea of a dopamine detox is a big one that I get asked about.
That was my next question, actually. Yeah, good. You're looking at my notes. What's going on here?
Right. And that concept does make a lot of sense. If you were to get rid of all your dopamine cells in your brain right now, you would be catatonic. You would be unable to do anything, good or bad, for you. You would basically have Parkinson's disease, which is a neurodegenerative disease where your dopamine neurons die. If in mice, we can do this in a way that obviously you wouldn't do it in a human, but in mice, if you essentially kill all the dopamine neurons, they will sit still until they die of starvation, basically. Right. This is clearly not what we want. And that's, makes, I think, obvious the idea that completely getting rid of dopamine somehow is not the goal. Right. But I think that the goal of the idea of dopamine detox probably has a grain of truth in it, in the sense that it's an idea of take a step back, think about what you're doing, reevaluate what's giving you pleasure in your life and try to sort of be mindful about it. That is not necessarily a bad strategy, but the idea that it's somehow reducing dopamine in your brain and that's going to be a good thing isn't very well connected to science.
But it's sure a fun phrase. I mean, it works great for clicks, right?
Right. And, the more that I have thought about this, since I have been asked about it a fair amount, what I think that people are looking for is sort of a justification for some of these wellness behaviors they've found helpful in their lives. And, it's not bad advice to have a good sleep schedule, to wake up and get some sunshine, to go for a walk. All of those things are excellent ideas. But just being careful then about what the neural substrates are mediating those good effects, I think, is important, just from the point of view of not over sensationalizing things to the point where you maybe do something silly, like take a weird supplement someone sold you that's supposed to solve the problem, right? Because that's going to get you in trouble. And so I think, as with anything, some of these online influencers, what you need to pay attention to is really who they are, and if they're trying to sell you something.
Follow that money.
Right. Follow that money, follow their incentives. And you may find that a lot of people are just trying to potentially take advantage of vulnerable people, which is a problem.
Right. If you could give one red flag for people to look for in phraseology around dopamine, is there something that kind of pops in the top of your mind with that?
Well, like you said, people are still talking about dopamine as a pleasure molecule. I mean, that's clearly outdated. And then I think also just using some of these buzzwords just are a little bit silly, I guess. Things like optimize your dopamine or maximize your dopamine or whatever they are. I mean, I think they're just meant to sound exciting. But again, they don't really communicate the science. And so I think sometimes when you see people relying only on buzzwords, it just may be because they're not really wanting to engage with some of the real science, basically. Yeah, exactly.
All right. So it does play, if I'm understanding correctly, it does play a role in motivation. It nudges us towards specific activities, specific pursuits, and maybe also helps enhance our decision making. Can you talk us through that a little bit more? You've touched on it. I loved your phrase, enabling learning about unexpected events. Can you continue to build on that for us? Because I think that is incredibly valuable. And then the way it can help us with motivation and nudging us and maybe helping with good decisions as we move through our days, our lives, et cetera. Just free flow, whatever comes to mind along those topics, because I think this is incredibly valuable for the coaches out there, but also for any individuals, parents, teachers, managers, et cetera.
Yeah. So one thing that keeps me in the job, that makes me want to study dopamine, is that it is a really complicated system, right? Study. And part of the reason that the buzzwords don't make sense is because dopamine, it does a lot of things, right? You just named a lot of things that it does, it's all about learning and decision making and motivation and all these different aspects. And it's involved in all these different disorders as well. We can say, it's an important player in depression and addiction and OCD, in schizophrenia, in ADHD, like all these things. So like, how does dopamine do all of these things? And the thing that's really become apparent in the last 10 or 15 years of dopamine research is that dopamine is not some molecule that your brain is just sort of bathed in and does one thing. Dopamine is a neurotransmitter that gets released in very specific neural circuits, and exactly which cells release it and what neural circuits those cells are participating in kind of changes what it means, because it means something only in the context of a neural circuit. A tube of dopamine in a lab without a brain, like it doesn't mean anything. It's just like a molecule in a tube, right? So a lot of my research and others has focused on really trying to pick apart these sub-circuits within the dopamine system and say, well, what does this part do? What does that part do, right? And the commonality is that they're all involved in some form of learning. But the ways that they do that are kind of fascinatingly different. And so, for example, we find dopamine signals in certain parts of the brain that go up for bad stuff. Now, if dopamine was just a pleasure molecule, right? Like, why would dopamine release increase when something bad happened to you? Right. But if the idea is that increase in dopamine when something bad happens is enabling you to learn what just happened to me, what caused that, how can I avoid the bad thing in the future, then it like starts to make sense.
But if it's triggering for a bad thing, how does that help with the learning process?
Right. So, I mean, a lot of what you're trying to do is you kind of like wander around the world and things happen to you is figure out, well, which things did I cause and which things are random and which cues might predict that, I might be able to find a reward or there might be danger nearby. And how do I differentiate between them? Like if I hear a bell, was that bell the bell of an ice cream truck saying I can go get an ice cream cone, or was that bell like a warning signal saying there's a fire, right? So trying to learn about, what are these things that are both important, right? Running away from a fire and running towards an ice cream truck might both be useful things to do, but you got to know like which one you should be doing, right? And so dopamine is kind of trying to help you learn about like what are all those cues in your environment? What are they connected to? Often they're not like deterministically connected, right? It may not be that every single time you hear a fire alarm, there's really a fire. There's lots of drills and there's lots of accidentally setting off the fire alarm, right? But like there's probabilities of like it might mean that. Maybe I should check, right? And your dopamine system helps you learn about that too. Like what are the probabilities of bad or good things happening? Or even, you know, sometimes those things are happening at the same time, that you might know that, oh, I might be able to get something good, but I'd have to, you know, it's risky, right? So there's a lot going on in the world all the time, and trying to figure out causality is like a major thing that allows you to choose your actions in some kind of like rational way, right? So all of this is important for good decision making.
Okay, so the decision making, the nudging, all those kinds of things, is it on a practical level, how do I or can I tune into, okay, that dopamine hit was a good thing. That dopamine hit, and I'm using the wrong phrase, you wouldn't say a dopamine hit, but that neurotransmitter released in the neural circuit, I think was your wording, is happening with this activity, which is good, and this one is happening with this activity, which I would like to eliminate. Can I differentiate? Can I recognize? Or is that the mindfulness piece where you literally are just having to do that? You just have to tune in or journal or think through on your day of, ooh, yes, but.
Right. So your brain can tell the difference. Like part of the way that we differentiate between, say, the dopamine signal that's signaling something about value or unexpected value versus something that might be signaling just salience, that something's important, versus something that might actually be signaling something bad is learning, is it depends exactly where in the brain you look. And so we can like move whatever, like our recording electrodes basically around to tiny different little spots in your brain, and you can see different signals encoding different stuff. So the idea is your brain can tell the difference between these things because it's where the dopamine is getting released. And so like on to what downstream neural circuit matters, because different circuits are sort of set up to interpret dopamine in different ways. So that's where this sort of whole circuit computation comes in. And what dopamine is kind of doing is like opening a period when you can change the weights of the synapses, meaning the connections between neurons. So there might be a circuit where you want to sort of change the weights of these circuits a little bit every time something bad happens, and a different circuit where you might want to change around the weights every time something good happens. But this will happen basically in different spatial regions. So there is a way for your brain to read out this code. But the part where the mindfulness, I think, comes in is that you can try to build models of like which things in the environment cause the good or bad thing to happen that can help you connect over time, if that makes sense. So, you know, if you're sort of trying to like multitask many things, like you're eating a sweet treat while you watch your favorite television show, right? It might be harder for your brain to kind of figure out, like, is it the excitement of the television show, or is it the, you know, excellent caramel popcorn I'm eating that's like causing this signal? And it's trying to form associations, but the more overlap there is between things, the harder that like computational problem might be.
Okay, so maybe this isn't true, but a trend I've noticed in my own life and many other people is when you're off the rails, it's easier to go further off the rails. When you're on the rails, it's easier to get on a better rail. So, and what I mean by that is essentially if I'm having a rough day and I'm not sleeping well, I'm more likely to eat junk food and sit in front of the TV show you were talking about, or have an extra glass of wine, or these things. When I'm feeling good and I slept well and I've been working out, I'm even more likely to eat better and all these things. Is our conversation overlapping that piece at all? Is it a craving for something in the midst of, my life's falling apart, I just need something? Or I don't know. It's just the time when we need to make the best decisions is when we make the worst decisions. And the time when we probably could get away with a few bad decisions is when we make even better decisions. And it's always been curious to me. Just any insights along those lines?
Yeah, I think there are a few insights. I mean, one is that people have studied the influence of stress on the dopamine system, and in particular, the influence of stress on your propensity to develop habits. And I think that also has to do with sort of decreased executive function that perhaps might result from lack of sleep or whatever it is. So the more that you have sort of good thing that habits do for us, right, is they reduce the sort of cognitive load of decision making. If you can fall back on a habit that you have, you don't have to think very hard about what you're doing.
Right.
And so when you're tired and overwhelmed, a way for you to save energy is to rely on your habits. And perhaps even to sort of further try to automate things to take a load off. And so I think that idea may be related to kind of what you're talking about, where, right, like if you're in a stressful situation and you need something to offload, you may rely on habits. And the more over the years that you've built up good habits, maybe you can use that to your advantage. But in the case where you're trying to get on a new good track, you sort of need to make yourself more goal-directed as much as possible and avoid falling back on those less helpful habits that you've kind of developed over the years. Right. And it's and the less kind of capacity that you have to do that, the harder it's going to be, because it requires quite a lot of executive control to like hold back from engaging in some of those bad habits. But your brain recalibrates over time. So even like with something like sweet taste, right? If you stop eating so much sugar, when you go back to that sweet treat you liked, you may say, oh my God, this is way too sweet, right? But if you've been eating sweets, you don't even like register that. And I think that also, at least partially, right, is explained by the idea that dopamine is detecting something unexpected. If you're really, really used to sweet flavors, it's not unexpected that the flavor is going to be sweet. And if you're not used to sweet flavors, an occasional sweet may be more salient to you.
All right, let's stay on habit change for a bit, because I know you've done a lot of research in that area. We have had Wendy Wood. I don't know if you've met Wendy at USC, Good Habits, Bad Habits. She spoke at our retreat a couple of years ago. And then a couple of Stanford folks you may have overlapped with, BJ Fogg and Kelly McGonigal. Habit change is so fascinating. It's so valuable, so important. What, in addition to what you've already talked about, what are we learning about habit change that maybe folks haven't tapped into or aren't aware of as they're trying to move through this journey?
Right. Habits are still something that I think at the neural circuit level, we're really trying to understand exactly what happens. And how much what you do is sort of a mix of these goal-directed versus habitual strategies. So I think that there's actually like a lot of interesting basic science that could happen that might help people think about this. And in my heart, I guess I am a basic scientist, so I'm almost more like about what we don't know yet that we need more research on than all the things that we do know. But we do know that, habits are more likely to emerge with repetition and with sort of somewhat irregular rewards that encourage you to kind of just pattern match, basically, rather than if you get very regular rewards for an action, you can actually stay more goal directed, partly because it's easier to match the action to the outcome and say like, oh, well, if I want B, I should do A. But when things become a little bit irregular and unpredictable, that's actually when you see the habit system being engaged more, because you're sort of just trying to figure out how to deal with probabilities and one, it's kind of harder to build a model, and it's perhaps more efficient just to say, I'm just going to estimate this and perform this action in this context or whatever it is. So I think staying aware of that, depending on whether you're trying to build a good habit or not form a bad habit, can be important. Things like slot machines are built on the sort of type of reinforcement that encourages habit formation, where there's lots of lights and sounds, there's lots of things telling you something important might be happening, and then the actual reward is sort of very rare and unpredictable, right? And that's exactly the sorts of reinforcement schedules we see in animal studies that encourage habit formation.
That almost seems opposite to what we learned in Psych 101 with the bell ringing, feed the dog learns to do X, Y, Z. Build this out a little more for us.
Right.
It's really interesting.
Right. So what you're talking about is Pavlovian training, this sort of famous experiment of you ring a bell and then you give the dog food. And after a while, the dog starts salivating when it hears the bell because it knows the bell is predicting that food is about to come. And we can do similar experiments in mice. It's probably one of the most reliable things we can do. So if you give a little light and let the animal lick a spout with sugar water, after a while, it'll start licking the spout when you shine the light, like before the sugar water comes, right? So it's just exactly the same idea as Pavlov's dogs, right? That Pavlovian learning depends on dopamine release in a part of the brain called the nucleus accumbens, which is actually a brain area that's important for reward learning, but not habit. And the dopamine that seems to be important for habit formation actually is more in an area in rodents that we call the dorsolateral striatum. In humans, we call it the putamen. But so it's a different brain area, right? And then there's this question of how does initial dopamine engagement by reward learning in the nucleus accumbens get transferred towards the putamen or dorsolateral striatum. And that's the transition that actually encourages habits to form rather than just learning about cues.
So, okay. So how do I do that? So I'm trying to, I'm trying to go for a walk every day. I'm not an exerciser, and I've decided I'm ready. I've been talking to my coach. We've got this plan, and I'm going to do it. But it seems like it's going to be regular. I'm going to walk outside. I'm going to get the sunshine. Like, there's pleasures to that. But how do I engage this irregular piece that tips off that actual habit change versus just the goal directed, I need to walk every day?
Right. I think that is a challenge. I mean, so we do know that repetition helps. And so the more that you repeat that action, the more you will develop a habit. I think that the other thing that can help is like paying attention to what the good outcomes of that behavior are. And sometimes those are regular. And especially if you're not a person that inherently gets lots of pleasure from exercise. Like, some people already like exercise. Yeah,
exactly.
Right?
I'm like, yeah, more time.
And to be honest, I'm kind of in that category. I enjoy exercise for many reasons. And it's not just physical. It's like a time to clear my mind, a time to go outside, potentially.
Time with the dog.
Right. Potentially going with someone or going with your dog. Right. But I think for people who don't like exercise because they're like, oh God, my legs are going to hurt when I run. Building in, some mindfulness about the other rewards that we just mentioned of like, well, maybe it's time to spend with my dog, or maybe if I go with a friend I wanted to talk to, or, maybe if I try, a few different trails where I can see some new scenery, you can try to build in other types of rewards with that exercise routine. And then eventually, I think there's a hump when you're out of shape and getting in shape where exercise is like really painful and you're sore. But if you can build in some other rewards to sort of get yourself over that hump, then you start to see, these longer term benefits of exercise. Like, now I have more energy. Now I'm stronger when I'm trying to do other daily tasks, right? Now sleeping I can work better. Towards doing that big hike when I go on vacation and to some spectacular site, right? So you can like build other goals in to your exercise routine that do only occur irregularly, but sort of are ways that you can find to think about the outcomes of your action in different ways.
So that recognition piece can be a trigger of some sort.
Yeah, exactly. And like in the exercise example, I guess the one thing to keep in mind is I would not suggest using the reward for exercise being that you get to eat a donut, because I think people often do that. And if your goal is weight loss, that pretty much counteracts the whole purpose.
Well, and the research is clear. We underestimate what we're eating and we overestimate our exercise levels. So usually,
but there's lots of other rewards, basically.
Totally.
That you can think about that come with exercise.
Totally. All right. You've done some research on compulsive behaviors, and it's super interesting. Talk us through some of the discoveries you've made in that arena.
Yeah, sure. So, in terms of compulsive behavior, at least, there's a human definition, which has to do with sort of a feeling of loss of control over your behavior. In animals, we can't really ask them whether they feel like they're in control. But what we do is we define compulsive behavior operationally as the inability to withhold from behavior when negative consequences start to occur. So basically what we're doing is we're training mice to do a little nose poke response. They basically poke their nose in a little hole. They do a nose poke response to get some sugar. And they do this over time, and they do this actually on the schedule that I kind of described, what we call a random interval schedule, which is they get rewarded sometimes for this, but not all the time. And it's a little bit unpredictable. And this causes them to poke their nose in the hole a lot. And then we start to introduce a potential punishment. And so the studies that we've done, they come with sort of a mild foot shock, basically. Not enough to really hurt them, but kind of like getting a static shock when you touch the couch in the winter or whatever. And that comes with, like, it doesn't happen every single time, but there's a probability. And so you can see individual differences actually in the mice, interestingly, just like you see in people, about how they react to that sort of newly introduced negative outcome. And some mice will stop asking for sugar when there's a potential to get a shock, and some mice will keep going. And then what we did is we recorded dopamine in various parts of the brain while the animals were doing this behavior, and asked, like, are there particular dopamine signals that predict whether a mouse is going to be punishment resistant, meaning it keeps going when there's punishment, or punishment sensitive, meaning it's going to stop. And we found a signal in a part of the striatum called the dorsomedial striatum, which is the caudate in humans, that predicted the individual responses in the mice.
And it's different.
Yeah. So it develops differently, sort of at different rates in the different mice as they learn this task. And the degree to which these signals develop in the dorsomedial striatum was able to predict which ones would sort of give up when there was a punishment and which ones would keep going. And we did some manipulations as well. So we have a technique that we use called optogenetics, which allows us to basically make certain neurons sensitive to light, so that we can experimentally turn on dopamine neurons with light, or turn off dopamine neurons with light. And we can do this in the animals, and we can see some really fascinating patterns where if we actually turn on dopamine neurons when they're learning about these rewards, we can accelerate this transition towards punishment resistance. And if we turn them off, we can decelerate it. And the pattern, the timing matters very much about when we time that turning on and off. So actually the off part is kind of interesting, because if we turn the dopamine signal off at a very specific time, we can make less punishment resistant mice. And if we turn it off at a different time, we can make them more punishment resistant. Wow. So this is the other aspect of dopamine that I think is like very nuanced, is like the timing is very important, because it's trying to detect sort of coincidences in your environment. I did this, I got that. I did this, I got that. That it has to be on at exactly the right time to do the thing that you want to learn. And so we can see that really nicely, like in these very controlled experiments. So that has been a really interesting story, I think, to follow on. And we've been thinking a lot about what it means as well, because the other thing that I always like to remind people about this kind of paradigm of punishment resistance, when you call it compulsive behavior, it certainly sounds bad. We don't like to be compulsive. You associate that with sort of addictive behaviors. Sure. But, there's also a flip side of the coin, which is the idea that there are times in your life where things are hard and you need to keep going when things are hard, right? So there's two sides of the coin of like, sometimes we'd call this resilience or grit. Yeah. Sometimes we'd call it like, oh, why are you hurting yourself on purpose? And figuring out the difference between those two things is like sometimes not obvious.
And these are not different breeds of mice. These were differences within the same genetic everything else, right?
Yeah, exactly. And in fact, the lines of mice that we use in the lab are pretty inbred lines, basically. So they're very genetically similar. For consistency's sake, yeah. Exactly. But we still see a lot of individual variability in the behavior, which is fascinating to me, right? Because you still get all this variability, even individuals. I mean, if people out there know identical twins, there's lots that are similar about them, but they're also different people, right? And we think a lot in my lab also about the influence of environment. And we're really interested in how, especially early life environment, influences the development of the dopamine system, which seems to make a big difference. That's on top of whatever genetics are driving that development.
Keep that one rolling. What changes, what settings, what support systems, et cetera, do influence it in, I'm not going to say good or bad directions, but to the right or to the left.
Right. And so there's this very sort of strong finding actually in sort of human epidemiological studies that early life, sort of what we call adverse childhood experiences, which are things like abuse, neglect, various kinds of household dysfunction, those experiences in childhood and adolescence are very strongly correlated with neuropsychiatric risk later in life. So people have higher rates of depression and addiction and anxiety disorders, and actually also other problems that aren't brain problems. But the question is, how does then an experience during development have this decades long impact? Right. And the idea is it's through some kind of developmental trajectory. So in mice, we can kind of try to recreate these conditions. And again, the nice thing about doing that type of research is it can be much more controlled. Like in human populations, you're just relying on like random chance of things that happen to people. And obviously people have all sorts of things happen to them and all sorts of different ages it happened. And it's hard to control.
Right. Far too many variables.
But in the mice, we can keep them in these identical cages, and we can just very specifically give them perturbations, at exact developmental time points, and see, does it matter if we stress them out when they were a baby versus an adolescent, for example, and how does that influence dopamine development? And I mean, those studies are really still underway, but the short answer is yes, it has an effect, and the effects are dependent on developmental timing. But so, for example, when we expose the mice to stress during adolescence, we see a really big increase in this compulsive behavior. And that seems to be related to changes in dopamine in their brain. And so we're like further trying to explore this and understand exactly what changes and why, and like which genetic programs are actually changed by experience to cause it. And all of that, I think, hopefully in the end will be helpful to inform treatments for people, by understanding that, there are things in a person's history that influence kind of how they are set up to do decision-making processes that are dependent on dopamine. And I think it may be important for differentiating, there's probably different mechanisms leading to, say, depression in different people. And, thinking about how to further refine diagnoses could really be helpful for identifying optimal treatments for people, because right now our approach to, for example, treating depression is really a lot of trial and error. Really, we have a few classes of drugs and we essentially just give you some antidepressant and wait some amount of time and it works or it doesn't work, and then you can try another one if it doesn't work. But we don't have great systems for like really predicting who's going to respond to what treatment very well.
And I know this is really early stage, but are we finding, you said it's somewhat generic at this point, are we finding that when we can trace the anxiety, depression, some of these other things back to those adverse childhood experiences, treatment X could potentially be a little more valuable, or even just the person tuning in to that potential influence can be more is there anything there that we can tap into? And I know this is so early stage, but just maybe some of your thoughts about where it's going, if not.
Yeah, exactly. And so like there's a million factors that I can think of that, hopefully we'll be able to follow up on. But I mean, so there's which drugs might help you, which type of antidepressant or whatever it is. And we can think about, who would be helped by different types of sort of pharmacology. But I think that we can also think about, for example, if you're predisposed towards a certain type of decision making because of the way your dopamine system developed, like maybe you're more prone to habits or less prone to habits, right? I think you could also think of ways that would play into like cognitive behavioral therapy approaches. So I think it's both. And then the other thing that my lab is really interested in is we have seen sex differences in how dopamine neurons respond to stress hormones. And probably that has to do with interactions between stress hormones and sex hormones. But better understanding that, I think, could also help us tailor therapies, men and women, but also just like hormonal status is important. We know that like there are vulnerable periods for depression, like postpartum, right? When hormones are changing a lot. And so like the idea of understanding those mechanisms and then how they're influenced by those periods of change give us ideas of how to specifically address what's happening in that period that might be different from like generic depression.
Right. What if we flip the coin? Are there precursors you're finding to the super driven individual that happen in child? I mean, I'm looking at your bio and just going, really? Like, I thought I was doing pretty well until I look at your bio, and then it's like, oh my gosh, this lady's done everything. Congratulations on tenure, by the way. You just got that news, so that's awesome. Yes. But on the other side of the coin, are there certain things that parents or settings or whatever we're finding are creating or setting the stage for, setting a stage for the super driven athlete, individual, entrepreneur, academic, etc.?
I think so. I mean, on the side of basic studies, in addition to stressing our mice out, we also are experimenting with environments that are enriching in various ways. And enrichment could mean either just stability in the environment, predictability, warmth, maternal care, things like that, or also enrichment in the sense of interesting things happening, more exposure to social stimuli, more toys to play with, more space to run around. And all of these things, seem to have some kind of influence, basically, and can kind of enrich your dopamine system. So result in sort of a more complex and more resilient dopamine system, and probably other brain circuits too, right? My lab focuses on dopamine, but
sure,
the whole brain is affected by your experiences. So, I mean, again, I'm always a little hesitant to like translate things completely into like prescriptions for parents now, but I would say that giving your children the space to explore is really important. That especially in the early years of life, a lot is learned through essentially trial and error, exploration. And Sometimes that's a little counterintuitive for parents to not completely control everything that happens to their kid. But there is a lot, I think, to be said for, if you want to encourage your child to understand how to learn, it's sort of a meta skill rather than learning a specific thing. It's just learning how to learn. They need to have those experiences of interacting with the world independently. And obviously you do that in an age appropriate way,
sure.
But I think those sorts of experiences build into then neurodevelopment of like, well, it's use it or lose it, right? Like if you're using these systems, those are the systems that are going to be elaborated. Right. And your brain, when it's developing, does this like massive transition. Basically, you form like all these sort of crazy extra synapses essentially in the first couple of years of life, and then you prune those away. So what your brain, an amazing thing that your brain is doing is it's sort of like setting itself up to learn almost anything. Think about a baby. When a baby is born, they could learn any language, like any language at all, right? And then a grown-up is going to have a very hard time, learning, I can't learn Chinese at this point. Like, I don't know. I'm not right. But if someone had taught me as a baby, I would totally know it. So your brain is like building up just all these synapses for learning almost anything you could possibly think of. And then it's pruning away the ones that aren't useful. And so the more that you use things, the more those are going to like stick around and allow you to have things around in your brain that you can use later. And so I think just thinking about that is thinking about what you're trying to do, I think, is essentially give learning opportunities, whatever those are. And that's the thing that enriches development the most, like much more than a specific skill. I'm a parent myself, and so I'm always like trying to figure out the right thing to do too.
Of course.
And it's always hard when you're like, oh, that person's 3-year-old can read already. Oh no. But like, I think in the end, the thing that matters for building resilient kids is not like whether they learned to read when they were 3 or 4 or 5 or 6. It's like just this confidence in their own ability to explore and learn.
Right. Well, and maybe they're different questions. So I'm hearing you say space, stability, and experiences builds that curiosity, builds the capacity to go in all these different branches that we've created. What about that driven piece, that person? So this is not necessarily something a parent does want to develop. It's the person that's can't turn it off. Mm-hmm. The entrepreneur, the athlete, the academic, et cetera, that they're not just smart and curious and engaged. They're go, and for some reason can't seem to turn it off. Is there any insight on those early stages that may be driving that? Because that's a unique individual.
It is. I don't know that I have a great neuroscientific explanation for it, but it's a fascinating individual difference. And again, something that you like perhaps learn to rein in over your life. I don't know. I'm more on the side of like, why can't I stop myself from trying to do everything? But I definitely see how there's a pleasant life if I didn't, right? Like there's a more relaxed life out there that's like that would be possible if I weren't driving myself crazy all the time. And some of it you can just make rules for yourself, right? I actually have a grad student who because he's sometimes coming into lab on the weekends because, the science requires a certain number of consecutive days of doing something, right? So like, okay, you're going to have to work some weekends. He keeps a list of how many weekend days did I work, and I'm going to take that many days off later. And I'm like, okay, do it. Right. That's a fair trade, right? Like people need days off. Right. But to make himself do that, he literally keeps a log of +1 for a weekend spent in lab means I got to get a -1 somewhere else later this month or whatever it is. And I think what that does is it helps prevent burnout, because you're not immune to burnout just because you're excited about your experiments in lab. Like, you still need a break. So that's not very neuroscientifically based, but it is something that is important to keep in mind. And it's something that can work if you have trouble doing it naturally, is just keep yourself accountable, right?
So let's flip the mirror. In what ways are you creatively integrating your findings into your own life, the way that you're living, the way that you're moving forward, the way that you're tweaking things and pursuing that next phase of Dr. Lerner in this world?
Right. Hopefully I can take my own advice. I mean, I'm definitely, my husband makes fun of me for thinking sleep is so important, but I'm definitely someone who thinks sleep is very important. I don't function very well without it.
I'm with you.
And with 3 kids at home, it's a little difficult sometimes. Yeah. But yeah, I mean, I think just the more you develop some of those routines of, like, sleep, exercise, that's something that, like, I found, if I don't, it's easy in the moment not to exercise, right? But then I get really stressed out if I don't. It's like an important anxiety release for me. And so I think, some of those things, again, that might not be true for someone else. So, like, a lot of my research is based on the idea that there are individual differences. Right. But finding the things that balance you. And this is, again, I think things like journaling are great. Like, if you are having trouble figuring out what those things in your life are that are adding positively or adding negatively, writing it down, trying to make some system to figure it out really, like, makes a difference. I think the other part of, like, just being a scientist that has influenced the way I live my life is the willingness to experiment. The idea that part of the reason perhaps you get stuck in a bad habit is because when you engage in a habit, you do the same thing over and over again, and you don't try another way, right? And every once in a while, it's a good idea to try another way and, like, check if there's something better out there. And if there's not, you can go back to your old thing, right? No worries. Go back to your old thing. Yeah. But, I think that also that sort of spirit of trying to make sure that I'm overcoming that resistance to trying something new, I think that gets harder as you get older, honestly. But I try to remind myself to dare myself to do new things, because it's the thing that keeps you learning and excited and, like, always finding a better way to do it. And I don't know, it always in the end pays off, even though it's, like, scary sometimes.
It's all about growing older, not getting older.
Exactly.
Yeah. Last question, and you touched on a couple of these. You mentioned the GLP-1 agonists earlier, but emerging research areas in the studies that you're involved with, dopamine behavior change, that gets you most excited. What's coming down the path that you say, we don't know yet, but we see potential for X?
I have to think. I think that there is a lot of potential. The GLP agonists are exciting because it does seem like there's some unknown mechanism there that's generally acting on sort of craving and motivation. And the other thing that I'm excited in by the basic research is the fact that I think we're getting closer and closer to more precision tools to target the dopamine system. So this idea I brought up before, that dopamine is not one thing, that there's specific dopamine subcircuits that do different computations. That is really important. And if we want sort of more precision medicine and psychiatry, then the tools to say, well, I want to design a drug to influence, the dopamine that goes to the dorsomedial striatum, but not the dopamine that goes to nucleus accumbens or something like that. Like, the more that we can say, it's not just dopamine, it's like this
not
dopamine.
Generic, right?
Then I think that we will be able to really, combine that, like, understand, which part of the dopamine system perhaps is dysfunctional in a person with addiction or depression, and then pick a drug to, like, much more specifically manipulate it. Because the problem with the drugs we have now that target the dopamine system is they cause a lot of side effects. So drugs that, for example, promote dopamine function in Parkinson's patients can actually cause addictive behaviors.
Interesting.
But that may be partly because if you just blanketly activate the dopamine system, you activate all of these different pathways rather than just the motor pathway that might help a Parkinson's patient move more easily. So the more that I think we understand the heterogeneity in the dopamine system and then build upon that by actually developing like drugs that target it effectively, like things that we can use in people, not just in mice, the more that we'll be able to really deliver things that address problems without, causing unacceptable side effects.
That's fantastic. That'll be exciting. Dr. Lerner, appreciate it. Great stuff. Appreciate you jumping on the Coaching Lab podcast. This has been fun, and we've been working on this interview for a very long time. So I'm glad it happened. Valuable time for it to happen, and keep up the great work.
Yeah, thank you. It was a fun discussion.
Thanks for joining us for this episode of the Coaching Lab podcast, the coach's #1 source for engaging evidence-based health, wellness, and performance insights. The last time I checked, there were 2.3 million podcasts available. So we're very grateful you decided to spend part of your week with us. For those coaches looking for best-in-class resources to build your toolbox or support your career, we have a wide range of options available on our institute site, catalystcoachinginstitute.com. You'll find specialty certifications in sleep and resilience or mental toughness. And for those who want to pursue certification for the National Board Certification, we're pleased to announce that Fortune Magazine rated Catalyst Coaching Institute the nation's top program. And our schedule for upcoming cohorts is available on that same site, catalystcoachinginstitute.com. And of course, reach out anytime if you want to discuss your specific questions about career, fit, all those kinds of things. Emails results@catalystcoachinginstitute.com. And now it's time to be a catalyst. This is Dr. Brad Cooper of Catalyst Coaching. I'll speak with you soon on another episode of the Coaching Lab podcast, or maybe over on the YouTube coaching channel.